subscribe.
Welcome viewers once again to Tito Labs. For some funny reasons, I'm a little clumsy this morning, so excuse me. Let me adjust my camera correctly, and I think that is fine. And also, I wrote a script for this intro, but to be very honest with you, I didn't have time to cram it, so I'm going to read it out from the piece of paper, okay? Now, technology is generally exciting, but beyond exciting, it makes life easier. And by easier, I mean convenient. And this is one major advantage of wireless systems. Remote controls is one wireless technology that offers convenience. Think of it. You could wirelessly control your light, your fan, just about anything you like to switch on and off periodically. Now, if you're interested, stay tuned and let me show you how to make a remote controlled switch. You see, nice speed. So if you're not very busy, join me. Let's do this together, shall we? Hold on, let me stop this.
All right, welcome back. This is the circuitry for the remote controlled lighting switch. And if you take a look at this circuit, you'll find out that some chips were used. This is a 555 timer IC. This is your CD4017. It's a decade counter, and I will come to that shortly. This is your infrared sensor, and this is your 7805. It's a regulator. Now, I will take our time to explain these things, so please follow closely. You'll be able to build yours after this video. All right, now, first thing you should know is that the whole circuitry will need power supply, and this circuit, I've powered it from inside this box. I used a 9-volt source, but you can use 12 volts. Okay, I used a 9-volt source, but look for a voltage source that can fit into the casing you want to use. The one I had lying around was a 9-volt source, all right, and it could fit into this casing, so I just use it. So 9 volt will work fine. All right, now if you look at this circuitry closely, you'll find out that the first thing we have here is this power supply would enter the input of this 7805. Now, this 7805 would give us a regulated 5-volt output that would feed this sensor, this 555 timer IC, and this decade counter. All right. Now, 555 IC can work with 5 volts. This can also work with 5 volts. But the major reason why we're using 5 volts to power the circuitry is the infrared sensor. If you use any voltage above 5 volts, you're going to damage the infrared sensor. The first time I built this circuit many years ago, I made that mistake. I kept on feeding it with the wrong voltages, and it kept on burning out. All right. Now, this infrared sensor, this is it. This is it. And then this is your power supply pin 3. All right. The power supply pin is this one. So this pin you're seeing here is this pin. All right. Now, pin 2 is the ground, the circuit ground. All right, which is this. Then the output is this. Okay, this is the output, and this is the pin here. All right. So if you are building this, just follow this pin out. You will get it correctly. But make sure that you are feeding this pin with maximum of 5 volts. If not, you're going to damage this infrared sensor. All right. Now, some other things that were used was we have a 1000 microfarad capacitor at the output of this. This is just for us to have a good current bank to feed the chips without hitches. All right. Now, also we have this LED here to tell you that the system is on. Okay. So this is a 470 ohm resistor connected to this LED and then to ground. Okay. That tells you that the system is on. Okay. Now, this particular capacitor is what we use to, keep the voltage across this sensor, as constant as possible. Okay. Now, take note, when current is flowing in the circuit, different things are happening. There might be times that the sensor might lack enough current to function fine. So the current stored in this capacitor would help to keep it working, properly within that period of time. Okay, so that's it about our infrared sensor. Next is the 555 timer IC. Now, timer ICs, these 555 timer ICs are very versatile. Okay, but I'm going to be showing you how it is used in this circuit. In this circuit, it was used as a monostable timer IC. And what I mean by monostable is when you trigger it in pin 2, what happens is it does one thing and stops. Okay? When I trigger it, it does one thing and stops. One thing you should also note about 555 timer IC is that your trigger is what makes it start to do what it should do. Okay? Now, the trigger pulse should be a negative pulse. If you feed pin 2 with a positive pulse, it will not respond. The 555 IC won't respond. Okay, so you should trigger it with what? A negative pulse. Okay, now this is your 555 IC. On this circuitry, we use this particular pinout so that it will be convenient for us to draw out the circuit. But in real life, this is the IC, and this is pin 1, counting from the top. If you check, there's a place where it's like there's a U. You count from the top. Pin 1, pin 2, pin 3, pin 4. This way, 5, 6, 7, 8. Let me take it again. Pin 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's it. Now, if you look at it on this circuitry, it's not exactly the way I told you, but when you are trying to build yours, please follow that pin out. It means that this pin 2 is this one here. This pin 1 is the first one here. Pin 5 should be this, and pin 3 should be 1, 2, 3, this one. Okay, pin 7 is this, pin 6 is this one, and then pin 8 and 4, this is pin 4, and this is pin 8. Okay, so that's how you number your ICs. All right, now, like I said, the 555 is wired in monostable mode. There are other modes for 555 IC. You have astable mode, you have I think bistable mode, but this one was wired as monostable. Monostable means, like I said, it's going to do one thing and stop. All right, now what happens here is this. Remember, we're feeding this with around 12 volts, then we'll have 5 volts coming out here. This 5 volts would now feed this sensor. Okay, so whenever this sensor senses any infrared, it will send out a signal from here. But the signal it will send will be a negative signal, which will now trigger this 555 IC. Once it triggers this output, pin 3, will come on for about 1 second, depending on the this resistor and this capacitor here. Okay, if you want to change the timing, okay, you just change maybe this capacitor or the resistor depending on which one you have lying around. Okay, now the formula for doing that is your T is 1.1 times R times C, where C is this capacitor here. Okay, now if you check any circuit where you have a 555 timer IC used, just check if pin 6 is connected with pin 7, you know it's a monostable mode. Okay, now the time this pin 3 will come on is given by this formula for monostable mode. Now let's predict how long this timer will come on after we trigger it in pin 2. The time would be 1.1 times the resistor value here is 100,000 ohms times the capacitor value is 10 times 10 raised to minus 6 farad. So let's see. If we do the math here using your calculator, you get approximately 1 second. All right. Now you can use your calculator to do that. It will give you approximately 1 second. So it means that when this infrared IC, okay, this infrared sensor senses any infrared, it will send out signal through this, it will pass through this capacitor here, which is this 0.01. That's written on it to be 104. You can refer to my video on capacitor codes to know your capacitor codes. But for this one, this is the capacitor here. All right. Now, if the 555 senses that signal, this IC will come on for roughly 1 second. Now, that signal it sends out will now feed your CD4017 pin. Now, CD4017 is a decade counter, like I mentioned at the beginning of the video. And what they mean by decade counter is that it counts in steps of 10. If you feed this pin with a signal, it will count 10 times and then start from the beginning again. All right. Now, we'll come to that pretty soon. If your 555 IC sends out that signal, it will send a pulse to this particular CD4017, and what happens is it does something which I will explain right now. Now, this is the pinout of your CD4017. Now, this is pin 1, 2, 3, like I explained for the 555 IC. I will not have to go into the timing counting anymore because I don't want this video to be too lengthy. But now, look at this. If I feed pin 14 with a signal, it's called the clock pin. If I feed it with a signal, it will send high signal. It will send signal to different pins depending on how many times I send a signal to this. Now, what this IC will do is this. If I send a clock signal into this, pin 3 will come on first. If that signal goes off, I send another signal to pin 14. Pin 2 will come on next. So you see that that's how it's numbered. If you check the data sheet, that's the way it's numbered, okay? So if I send a clock signal to this comes on first, this follows, pin 2 follows. Then the next one would be, where is 2 now? I have pin 4. Then the next one will be pin 7, which is 3. The next one would be, where is 4 now? Pin 10. The next one will be pin 1. Just like that. It will send out signals just like that, okay? So now see this. If this one sends a signal for about 1 second into this CD4017, the first pin that will come on is this. And so you will notice that on my project, one of the LEDs come on whenever it senses a signal, okay? And it comes on for roughly 1 second because these are the values I use, okay? Now, those signals feed this, and once it feeds it, it tells us that this guy has received a pulse, okay? That's what makes that particular LED come on. This is the LED now, okay? This is how you connect it to ground, okay? Now, if it receives another pulse, the next thing that will happen is pin 2 will go high. You see that pin 2 is what is connected to this transistor now, okay? So if I send a signal, this will tell me that this guy has received a signal. Then if it is the second time I'm pressing the remote, what happens is a signal comes from here to feed this transistor, okay? Now this is an LED with a current limiting resistor. This also tells us that this guy has received a pulse, okay? Now, if you check from what I've been explaining, signal starts here, triggers this for about 1 second, comes here to trigger this, and then your output comes out from pin 2 to feed the base of this guy. Now, this is a relay, and you must always use this diode across your relay coils. This is the kind of relay I used. This is the relay coils. This and this is what we have here and here, all right? Now, for this relay, this is your common, okay, which is this labeled COM, common. Common means if I energize this relay, it will move from the normally closed to normally open. So what we have here is this. When this relay is not triggered at all, this common will always connect to your normally closed. It means that normally the common is closed with this guy. All right. Now, if I, for some reason, okay, energize this relay, what happens is that this one will switch from here to this point. Okay, that's what will happen. So this one you're seeing is this on the diagram. All right. Then this NC, normally closed, is this. Then normally open, which is this one. All right. You see that it's very simple. Then of course this is your light bulb, which is this with the lamp holder, and then this is your AC input. This is where you feed your AC. Now take note, you can replace this bulb with any other thing you would like to switch on and off. You can replace it with a fan. You can replace it with just about anything you would like to switch on and off wirelessly with your remote control. Okay. Now this is the emitter of your transistor, and of course just put a 1K resistor between your pin 2 and the base. Okay. Now coming back to this, you should always make use of this diode across your relay coils anytime you are using a relay in a circuit. The reason is this: it is a relay coil and it's an inductor. So if current flows through it, voltage will build up across the coil. Now that voltage can grow way higher than the voltage that fed it in the first place. And if you do not have this diode here, that voltage, when it is de-energized, can collapse back into this circuit and damage your transistor. Okay. But what happens is, by the time the relay coils is de-energized, this relay, instead of collapsing back, this one will conduct it back to the power supply. Okay, to conduct it back to the power supply. And of course, before the current flows through that point, it will not cause any serious damage to your circuit. So always make use of this. It's called your freewheeling diode or something, I think. Freewheeling diode. Please make use of this. Very important. Very important. So that's just about the operation of this circuit. If you have any questions, please feel free to ask. I would like to hear from you. Please, it takes a lot of effort to do these videos. Give us a like. Please subscribe. All right. And I would like to hear from you. Like I said, if you have any confusions on what I've explained, please make sure you ask your question. But in case you enjoyed it, share the video with your friends. And of course, I know I'm a good teacher. I'm sure you probably understand it. Even if you understand it, please tell me, I understand this and I love the work you're doing. Encourage us to continue to do this. Thank you so very much, and see you some other time. Bye.